Hello everyone, today we are going to attempt a 6-part function question worth 13 marks, and this will cover most of the function concepts you have learned in H2 A-level math. Now starting with the first part, we are to describe a sequence of transformations which would transform the curve ln x onto the curve fx. A good way I like to start is to look at the x values first and compare them before and after the transformation. Now in transformation involving x values, x is pretty much like a naughty student and will go the opposite way to our math operation. Notice there's a negative sign over here, so let's translate 1 unit in the positive x direction. Since there's a 3 over here as well, we are going to scale this with a factor of 1 over 3 parallel to the x-axis. And lastly, a minus over here indicates reflection of all the y values in the x-axis. So there you have it. This is a full description of the transformation required. Now in part 2, we are required to sketch the graph of function gx. You could use a graphing calculator to help you with this, but always take note of the domain that we should be concerned about, which is 1 less than x less than equals to 4. Now remember also to indicate any asymptotes, minimum points, and boundaries of interest on the sketch. Now the info will go a long way to help you in the subsequent parts of the question. Now part 3 is where many students find difficulty in. Now before we find the range of fg, I'd always like to first sketch the graph of f, since we already have the graph of g. Now remember to indicate key information like the asymptote. Next, always remember the range of fg is simply the range of f, but under a certain condition, by restricting the domain of f to the range of g. Because for fg to exist, the range of g must be a subset of the domain of f. So we are going to restrict the domain of f to the range of g. The range of fg can thus be found by reading the range that corresponds to this restricted domain, which is from negative infinity, below, all the way to negative ln 2 inclusive. Now if you're wondering how I got negative ln 2, we can simply substitute 1 into fx to give us this negative ln 2 value. Now in part 4, we are going to restrict the domain of g such that g inverse exists. The condition for an inverse to exist is when a function is 1:1. Now in such questions, always try to observe what's the lower or upper limit of the domain. In this case, the upper limit is 4, so let's drop an imaginary vertical line to scan to the left such that we can find the minimum value that makes the function a 1:1 function. Very quickly, that value of x is 3. Because this is at the minimum point. Thus, when the domain of g is restricted to 3 less than equals to x less than equals to 4, the line y equals to b, where b is an element of a real number, cuts the graph of gx at most once. This makes g a 1:1 function, and therefore under this condition, g inverse exists. Now moving on to part 5, we are going to find the g inverse. All we need to do is to let y be equals to function g, and then we can make x the subject. We can use the completing the square method to simplify the denominator. This is so that we can combine all the x into one term over here. Next, cross multiply on each side of the equation to give us x minus 3 squared is equals to minus 4 over y plus 4. Now x minus 3 can give us a positive square root or a negative square root, but in this case we are only going to accept the positive square root, because from this restricted domain over here, x minus 3 must be a positive value. Now always be careful to verify this part, as it is a common mistake that many students will make. Now by making x the subject, g inverse is equal to 3 plus square root 4 minus 4 over x. Now part 6 is a challenging one where it is not so straightforward. Now since alpha 16 over 15 lies on the function gh, it means that if I were to feed alpha into this function, the output I will get is 16 over 15. Now to get the function h alone, what we can do is to introduce g inverse on both sides of the expression over here. Now this will safely remove the function g in front of the composite function gh. Therefore, h alpha can simply be found by substituting 16 over 15 into the g inverse function which we have found in the previous step. Now using our graphing calculator again, this gives us a nice value of 3.5. Now I do hope you have learned something from this video. If you have any questions or comments, do leave them down in the comments box below. And thank you so much for watching.